Well, g'day everyone, and welcome to the last lesson in week 4. Wow, time is certainly flying. And our title for today is following on from our live lesson on Tuesday where we did some factorising. We're going to look at more factorising today, but we're going to revisit the idea of the area of a rectangle. So your title is Factorising Area, and the date that you should be accessing this is Thursday the 14th of May. Obviously, if you have the class notes, as I always say, you should have those pre-printed in front of you. But if you're using your book, please take the time to write that down and pause anywhere in this video if you need to get something down. For example, the learning intent you need to write down says, apply the distributive law to factorise algebraic expressions with numerical factors, and we'll be particularly looking at the area of a rectangle today. The success criteria is to revise that the idea of factorise is the opposite of expanding. That's why we're doing things like dividing. And then to factorise algebraic expressions by identifying factors. Now, to start the lesson, as we always do, we always generally do a review. And this review here is going to review everything that we've looked at over the last 4 weeks. So as I said, this is towards the end of week 4 that you should be viewing this. And so we really only have one more concept to look at in our live lesson in week 5, and then potentially we'll be back in the classroom. So let's see how we've gone over the last 4 weeks. And here's a pretty comprehensive review. Now the first 3 parts here are basically just the index laws revisited. And then parts D and E, we're collecting like terms. With parts F and G, we are expanding. What I'd like you to do is I'd like you to try these questions yourself. Now, when you get down to the expanding, you can either expand algebraically, so using the distributive law as we showed you, so you can draw arrows from the outside term to the 2 inside terms when you multiply, or you can draw a rectangle off to the side and you can use that rectangle format to actually work this out and then multiply it out like that. I'll leave it up to you as to how you want to work out F and G. But what I would like you to do is to pause the video now for about, say, 10 minutes tops and attempt those questions. Obviously, if you're using your book, write the question out first. If you've got the notes, you've got the questions pre-printed. But I'd like you to spend 10 minutes on reviewing those questions, please. Pause the video now. Okay, how did we go? Let's check a few answers. So I would assume that by now we should have absolutely no dramas with the first 3 parts. These are the 3 basic index laws. The first one, the bases are the same and we're multiplying, and so we're just simply adding our powers together. 7 plus 3 equals 10. So G to the power of 10. For the second one, the bases are the same and we're dividing, so this time we take our powers away. So you'll have D to the power of 14, take away 5, so that's D to the power of 9. And the last one here, we've got h to the 8 raised to the power of 4. So we're raising a power to a power. And when we raise a power to a power, we multiply the powers together. And so you hopefully got h to the power of 32. So they should be, pretty much locked in and pretty solid. For parts D and E, the collecting like terms. Now the technique I showed you to collect like terms, and hopefully you showed this too, is to actually circle the like terms. So they're the only 2 like terms that are in part D. They both have the same letter or the same base, and they both have the same power. Remember to circle the sign as well, because that gives you the instructions about what to do. And so to collect those together, you're going to have 6n, and you're going to take away 4n, and that leaves you with 2n. Rewrite in the plus 8 because that's part of the problem. We can't collect those together, and so that's your final answer, 2n plus 8. Part E has a wee trick in it, and that is that I've rearranged the letters. But remember the basic rule about like terms is they have to have the same base, or the same letters, and the same powers. So you'll notice I circled both 10zy and negative 5yz. All right, they are like terms because they both have the same letters, which is y and z. Circle the sign again, and you've got the instructions. 10 take away 5 is 5, and generally we should write the letters in alphabetical order. And then you've got plus 3y, and that's it. We can't collect anything more. Now, in terms of the expanding down here, I might demonstrate both methods. So as I showed you, you've got the one that with the arrows, the algebraic way. So you're multiplying the number on the outside by both those terms inside the brackets. So when you multiply out using algebra, you're going to go 4a multiplied by 2a, and you're going to plus to that 4a multiplied by 7. Now 4 times 2 is 8, and a times a will give you a squared, so 8a squared. 4a times 7, or 4 times 7 is 28, so 4a times 7 is 28a, and no, we can't collect those together, so that's your final answer. Now with part G, I might demonstrate the area of a rectangle method, and I might just do part G up here on the top. So what you would have done is you would have drawn a rectangle, cut it in half, so you've got two little rectangles. The number that you're multiplying by, so in this case the 6, goes along the width, and then along the length of these two rectangles you put the two terms that are inside the brackets, and you just multiply it all out. So 6 times 2y is 12y, and 6 times negative 4 is negative 24. Now to get the answer for that one, you just fade that rectangle out, and you get 12y minus 24. And no, you can't collect any of those terms together. Now boys and girls, that's what we should know by the end of week 4, plus what we're going to do today. If you've made any mistakes on that screen, or there's something that you don't quite understand, could you make sure, one, that you write down the correct answers off this slide. You may need to pause the video. And then two, make sure you get in contact with me, Mr. Freiberg, so that we can get those problems sorted as soon as possible. Okay, let's move on. Now on Tuesday, I introduced you to the idea of factorising. Now factorising was the opposite of expanding. And what we did was we factorised by finding something called the highest common factor, or what we call the HCF. Now what I'd like you to do is to maybe spend 5 minutes factorising those two expressions there on the screen. So remember, when you factorise, what we actually need to find is the number on the outside, which is the highest common factor, and then we've got two terms inside the brackets. We find those terms by dividing, because opposites, factorising is the opposite of expanding. So remember, when we expanded, we multiplied. So when we factorise, we're going to divide. I'd like you to pause the video now for 5 minutes, and we'll see if we'll come back and we'll check the answers, and hopefully you've got them right. Okay, let's check. So remember, what I said is we need to first of all find the highest common factor of 30y and 5, and what I did the other day was we actually wrote these out as like a couple of little tables, and these are tables of factors. So for instance, what are the factors of 30y? Well, 1 times 30 equals 30, 2 times 15 equals 30, 3 times 10 equals 30, 4? No, that gives us a decimal answer, and we can't have that. It's 4 times 7.5, so we're going to stick to the whole numbers, as I told you the other day. And last one, 5 times 6, and we also have a y in there, right, because y is also part of 30y. Now what are our factors of 5? Pretty easy, just 1 and 5. And then what we need to do is we need to go through, and we now need to find the biggest number that's the same in both of those lists. That's called the highest common factor. Now I can see that I've got 1s and 5s. They're the common factors, but what's the biggest one of those? Clearly, it's the 5. And so the highest common factor is 5. So as I did, or as I said, when we factorise 30y plus 5, I put the highest common factor on the outside of the brackets, that's the 5. Now I need to work out what goes inside the brackets, and I can do this one of two ways, as I suggested to you the other day. The easiest way is to divide 30y by 5 and 5 by 5, and that will give you the two terms inside the brackets. So 30y divided by 5, 30 divided by 5 is 6, so 30y divided by 5 is 6y, and 5 divided by 5 is 1. The other way you could check is you could check the other factor that goes with the highest common factor, and you see that they also appear inside the brackets. Now, if you weren't sure about factorising, you might like to write that first one down, pause the video, and now try the second one. Let's check the answer for part B. So part B, we're going to do the same thing. We're actually going to find the highest common factor first. The highest common factor of 24a and 16a squared. So I list all of my factors of 24a, That's 1 and 24, 2 times 12, 3 times 8, 4 times 6, and that's it. And I've also got an a down the bottom there. Now remember, with the factors of 16a squared, we've got 1 and 16, we've got 2 and 8, we don't have 3, and then we have 4 and 4, but we also have a times a, because remember, a squared equals a times a. So it's important that when you write down a factor list, like we did in our very first live lesson together, you actually write down a squared as a times a. Now I go through and I find what the highest common factor is. So again, I look for the numbers that are the same, and I look for the biggest one that's the same in both of those lists. I can see 1s, I can see 2s, I can also see 4. I can also see 8. Can I see any other common numbers? No. So it looks like my highest common factor has an 8 in it. I can also see something else that's the same in both of those lists, and that's the a there. So in this one, my highest common factor is actually 8a. And I write that on the outside of the brackets down here. So 8a is my highest common factor. I now write down what I have, or write down what goes inside the brackets, and again, I can divide both of those terms by the highest common factor. Or I can look on my factor lists. Either way, 24 divided by 8 is 3. A divided by a, well, that a can't be rewritten. 16 divided by 8 is 2, and a squared divided by a means I've still got an a. You see, I still haven't circled that a, so that one there. So the final answer is 8a, and then in brackets, 3 plus 2a. Now again, boys and girls, if you need to write that down, please take the time to write that down carefully, because that's the answer for part B. Today, we're actually going to show you about the area of a rectangle in order to work these out as well. So let's take a look at that. Now remember, factorising is the opposite of expanding, and I showed you that diagram on Tuesday. If you'd like to rewrite it down, you can. Simply pause the video, put factorising as the heading, put the definition of factorising, and redraw that picture in your book. You have it in your notes already if you've downloaded the class notes. All right, let's have a look at the rectangles. So in factorising, when we do the area of a rectangle, we're essentially just finding missing parts. So we're doing the opposite operation, and we're working backwards. So working backwards to find what's missing. And then I remind you here that the opposite of multiplying is dividing. So we're going to be doing a fair bit of dividing. Here's an example that I'll step you through, and you might like to watch really closely. So this is what the questions look like. You'll notice that I have the answer down here. I've got the answer inside my brackets, inside my rectangle. I'll just add the plus 20 there. And what's missing is the two terms up the top here. So in other words, what's missing is the two numbers that go inside the brackets. That's what I need to find. The good thing is, I've already been given the highest common factor. There it is on the outside. The highest common factor is equal to 5. All right, that's the highest common factor. So I'm saying over here, think, what do I need, or what do I have to multiply by 5 to get 15a? 5 times what equals 15a? This is where the idea of opposite comes from. Because to work that out, working backwards, I simply divide. And you can see there that I now start with the 15a, I divide by 5, and I end up with 3a. So I'm going to put 3a up the top there. Watching again, if I start with 20, and I divide by 5, that will give me 4, because that's the number that's going to go up the top there. So here's my answer, 3a plus 4 inside the brackets. And what would be good is if we actually then wrote down the factorised form of that, which is 5 outside of 3a plus 4. Quick question, can you check your answer? Of course you can, because you can expand that back out and you should get back to where you started. So can you check? Yes. expand, and you'll get back to the starting point. Let's try a couple. Okay, so here's a couple of questions. We're going to work through these ones together. You obviously might like to try them yourself, but they will all involve a little bit of dividing. Now, if you look at the first one, I actually haven't given you the highest common factor. That's the highest common factor right there, and we don't know what it is. You could go and work it out, or you could actually use the fact that one of the numbers, or one of the terms inside the brackets, is 4t, which you can see there. Okay, so essentially I'm at a point of, I've got an unknown highest common factor. The first term inside the brackets is 4t. The second term inside the brackets I don't know, and that's what I need to work out. You might like to try and complete that question yourself. Remember, it's all about dividing, because factorising is the opposite of expanding, and so we're going to be dividing to get the answer. Pause the video now if you'd like to try that first question yourself. All right, let's check and see how we've gone. So what I would have done is I would have got the 24t, and I would have divided by that 4t that's up the top, because then that would give me what the highest common factor is on the outside. So like I said, it's all about dividing. So 24t divided by 4t would give me 6. So I've written the 6 on the outside as the highest common factor. Now, how would I work out what this second term is? Well, now that I've worked out that the highest common factor is 6, like I did on the previous slide, I'd go 12 divided by 6, and that would give me the missing number up there, which is 2. So you can see that the answer is 6 outside of 4t plus 2. 6 in brackets, 4t plus 2. If you tried that yourself, well done, you got it right. A little bit of feedback here. I actually find using the area of rectangles a little bit harder for factorising, because you could have a few missing parts. I think the area of a rectangle is easier for expanding, but for factorising, I think maybe if you could do what we did on Tuesday with finding the highest common factor, you might experience a little bit more success. But let's try the second one and see how we go. Now the second one's similar. The second one has a 2a squared inside the rectangle here, and it's got a 2a and a plus 1 on the outside, and we're again missing the highest common factor. So we're actually missing both the expanded and both the factorised form of the equation. All we've got so far is we don't know the number on the outside. We've got a 2a plus 1 inside the brackets, and then the answer is 2a squared plus something. So there's a fair bit of information missing. I want you to have a think about that one, and I want you to see if you can come up with an answer. I'll give you a wee clue. Start with the 2a squared and divide it by the 2a, and that might be a good starting point. So start with the 2a squared and divide it by the 2a. Why divide? Because that's the opposite of multiplying, because the factorising is the opposite of expanding. Pause the video now and come back and we'll check on your progress. Okay, how did we go? So when you do 2a squared divided by 2a, that just leaves you with 1a. So I think the highest common factor is going to be 1a. Now if you just wrote down a, that's fine. I'm going to write down 1a because it's a little bit easier to show. So 2a squared divided by 2a is just 1a. Now you can kind of see that now if I actually expand, I'm going to get what's missing inside the rectangle. So 1a multiplied by 1 is 1a. So I think my final answer is 1a outside of 2a plus 1, and the expanded version of that gets me 2a squared plus 1a. Let me check. Correct. So even though I don't have the 1 written in front of the A, that's a 1A there. See, a little bit tricky, but hopefully you had a go and you found those missing parts. Now, a little bit of a trick here is that they're not always necessarily going to be factorising. Most times you're just finding the missing parts on those rectangles. Can we recognise that factorise is the opposite of expand? And can we factorise by identifying factors? I think we can. Your turn, folks. Now, on the eLearn Classroom is a document that looks a little bit like that. It's another PDF document, and you'll notice that there are various missing parts in these questions. They might have the highest common factor missing. They might have some of the terms inside the rectangles missing. They might have some of the terms outside of the rectangles missing. You'll notice that there are 36 questions on that sheet, so there are heaps for you to complete. I'd like you to complete that sheet as your priority, and when you have completed it, please send me a scan or a photo to show that you have completed it. If there are any that trick you up, again, please ask. Tell me, say, for example, number 13 might be a problem. Please do bear in mind that a lot of these sums, you'll start off by doing some dividing, because that's what we're working on when it comes to factorising. Also, I have some extra problems. Now, these extra problems are basically just, can you factorise? So in other words, can you take out the highest common factor, and can you write, for example, this first one here, can you take out the highest common factor, which is 5, and can you write down the answer, which then is 1x plus 12? So each of these questions where I ask you to factorise, I want you to write it in the factorised form like that. Now, I don't mind how you work that out, whether you want to do the technique that we did on Tuesday together, which is to find the highest common factor. Between you and me, that might be a little bit easier. Or you might want to try the rectangle technique that we looked at today. If you have a copy of the notes, you'll find these questions on the notes. You'll also find a copy of these questions on the eLearn Classroom under additional textbook exercises. You could, of course, just pause the screen, pause the video, and you can attempt them off that. There are a few more as well. Question 5, question 6. Question 5, again, factorise by taking out the highest common factor. You'll notice that a couple of these get challenging because some of these have 3 terms in them. So you need to find the highest common factor of 3 terms. Write it on the outside, and then you have your 3 terms inside the brackets. Question 6 is a little bit of extension work because it's actually asking you to find the highest common factor that's a negative number. Can we recognise that factorised and expanding is opposite? Can you factorise algebraic expressions? I think so. Boys and girls, that's probably about it for looking at, say, algebra and writing some algebra. And that's taken us 4 weeks. Next week, we'll start looking at drawing some graphs. I look forward to receiving that worksheet, and I hope you have a fantastic weekend, and I look forward to speaking with you next Tuesday. Thank you very much again for all of your time and patience, and thank you very much for all of your hard work, particularly this week, given that it was a hard week and we got you to do a lot of fairly difficult work by yourself. Thank you, everyone. Have a great weekend. See you later. Bye.